Okay, in this screencast I want to have a look at the intersection point of two vectors and how to find that intersection point. And I'm going to draw parallels again, excuse the pun, with our work on linear relations, because it's very, very similar. So let's have a look at an example. So here it reads, two lines, and this is the last section we did, lines have equations. Okay, so equations, so we're going to have two lines, R1 for line 1, fixed position vector 3, 0, minus 1, and direction vector 1, 1, 1. That's R1. R2 is going to look like this. It's going to look a bit like 6, 2, 0 plus parameter t 0, 4, 8. Okay, so these are two vectors. Vector equations, and for different values of s we get different points, don't we? So again, if I say that I've got an equation y equals 2x plus 5, then for every x I put in here, so if I put in x equals 1, right, so I have y and x like this, or I might actually go the other way around with my independent variable x, so x, y, like so. If I put 1 in for x, I get 7 for y. I put 2 in for x, I get 9 for y. Right? This is, I don't want to insult your intelligence, but this is what we've been doing for years, and then we draw this up and we get a straight line. Now there's no difference here for this line. I'll get rid of all that. For this line here, for when I have different values of s, I get a different equation. So for s, I get a different point. So for s, let's have and this will be my position vector r. So for s is equal to 0, I've got 3, 0, minus 1. For s equals 1, I've got 4, 1, 0. For s equals 2, I've got, see what I'm doing here? So this becomes 2, 2, 2. I get 5, 2, 2 goes in there, minus 1 plus 2 is 1. So then if I collected all these position vectors, all these points, and joined them up, I'd have this vector, this straight line vector. So just like a line is just a collection of points, a vector is a collection of position vectors. So that's where all this fits in. Okay, so here's my 2 points. Hopefully that'll now help us. Sorry, here are my 2 lines. Hopefully that'll now assist us in finding the point of intersection. So the example, 2 lines have these equations, show that the lines intersect, show that the lines intersect. Now how do we show they intersect? Well, they're direction vectors here. Sorry, I'll get the words out in a minute. The direction vectors are not parallel. So direction vectors are not parallel because they don't differ by a scalar factor. 1, 1, 1, 0, 4, 8, not parallel, therefore lines intersect. Okay, so that answers the first part of the question. Show that lines intersect and find the coordinates. So if they're not parallel, they'll intersect, so therefore we can find points of intersection or the point of intersection. So find the coordinates of the point of intersection, show that the lines intersect, and find the coordinates of the point of intersection. Find the coordinates of the point of intersection. Okay, so let's now do that. All right, so this is how we're going to do it. We're going to write this R1 line. We're going to write that as a general point. So I'll show you what I mean. 3 plus s, 0 plus s, or just s, and minus 1 plus s. Minus 1 plus s. Okay, that is the point. So for different values of s, now I put 1 in for s, I get 4, 1, 0. I put 2 in for s, I get 5, 2, 1. Okay, so I'm just writing each out now as just a general position vector in terms of s, and in R2's case t. So it'll be 6 plus well, just 6, 2 plus 4t, and 0 plus 8t. Okay, so these are the general points. All right, so they're the general position vectors. And what we want is to find out where the common position vector is. And we'll do that by making 3 plus s equal to 6. Therefore, point of intersection at 3 plus s is equal to 6. We can get from that s is equal to 3. Right, that was easy. S is equal to, right, so that's the first one. S is equal to 2 plus 4t. Now, I've already found that s is equal to 3, so now 4t is equal to 1 and t is equal to 1/4. And we can test that with the last equation, minus 1 plus s is equal to 8t. S is equal to 3, so that's 2, and 8 times 1/4 is 2, so that's all good. So we've found our values of s and t, so therefore the point of intersection is, putting 3 in for s, we get 6, 3, and minus 1 plus s, which is 2. And if I check that over here on my R2 equation, I get 6. When t is equal to 1/4, I get 2 plus 1 is 3. So 2 plus 1 is 3, that's right. And 8 times 1/4 is 2, so that all checks out. And there's my point of intersection. Okay, short and sweet for possibly our last screencasting lesson of the course. We're going to now be ready to do exercise 12K, which is all about finding intersection points, and then that'll lead into 12L, which is application of vectors, and then that's the end of the vectors section. So I'll see you in class. Cheers.